Hi everyone, my name is Pradyumn, and today we will be having the PCD for today's Leetcode contest, which was weekly, and we will solve the problems from A to D, all the problems. But before we begin, I'll tell you about our courses at TLE Eliminators. So if you are someone who is stuck at just solving one or two problems per contest, then our self-paced courses are what you need. So we have structured the program into 4 levels. So you can start from wherever you are, whether you are a beginner or you are a pre-intermediate or you are intermediate or you are an advanced. Okay, you will learn the most relevant CP concepts through video lectures by experienced educators, followed by practice problems combined with guided hints and video solutions that help you understand the why and not just the how. We believe in helping you build real intuition. And if you need more help, then you'll get instant help, like you'll get instant doubt support from our top rated mentors, so you're never left stuck. And beyond just learning, you will enjoy leaderboards, progress tracking, and internal contests and PCDs to keep you consistent. Okay, and if you are not sure that which level you should choose, then you can watch this video, which will tell you how to choose a level. And if you're still not sure, then you can watch the video which is given in the level. So like it will tell you about the, like, for that course, what are the prerequisites, the outcomes, the difficulty, and the topics. All right, so let's begin now. So this was today's contest 482, and the problem A was this one. Okay, it is called maximum score of a split. You are given an integer array nums of length n. Choose an index I such that I is between 0 to n minus 1. I is greater than or equal to 0 and less than n minus 1. So it can't be n minus 1. For a chosen split index I, let prefix sum of I be the sum of nums 0, nums 1 up to nums I, and let suffix min of I be the minimum value among nums I plus 1, nums I plus 2 up to nums I minus n minus 1. The score of a split is defined as prefix sum minus suffix min. Return an integer denoting the maximum score over all valid split indices. Okay, so like they are saying that we have been given an array, right? Let's say a1, a2, a3 up to an, right? Or actually they have indexed it from n minus 1, like from 0 to n minus 1. So a0, a1, a2 up to a of n minus 1. And they are saying that for an index I, the score of index I is defined as the prefix sum up to I. So like a0 plus a1 plus up to ai, right? Prefix sum minus suffix minimum. So basically minimum of a of I plus 1, a of I plus 2 up to a of n minus 1, right? They have defined the score of I to be like this, and what we have to do is we have to find out the maximum possible score. Like we have been given this array, and we can choose any I from 0 to n minus 2, right? We cannot choose n minus 1 because in that case this suffix would be empty, right? So we can choose I from 0 to n minus 2, and we have to figure out that what is the maximum possible score, right? So in this problem, one easiest possible solution would be just to check for all I, right? Like you can just iterate over all the I, that is for I is equal to 0 to n minus 2, right? And then you can simply calculate this quantity. Like you can simply run loop of j for j equal to 0 to I. You can simply do sum plus equals to aj, right? And then for j equal to I plus 1 to n minus 1, you can take the minimum. So the mi is equal to min of mi comma aj, right? So you can simply do this. This is O of n square. That's the problem. Like, this is possible, but it is O of n square, right? Because in you have this outer for loop, and inside you have these for loops which are, this is O of n, right? This entire thing is O of n, and it is running n times, so it is O of n square finally, right? So this is O of n square, but can we do better? The question is that can we do better? Like, okay, finally what you will do is, like, take the maximum possible value of sum minus mi, right? That is pretty simple. That is O of n square solution. But can we do better than O of n square? That's the question, because here the constraints are what? Constraints are that n can be up to 10 to the power 5, right? So what can you do? You want to calculate this value, right? So actually the main idea here is you can still iterate over all the I, right? You can still iterate over all the I from 0 to n minus 1, I mean n minus 2. But then you can calculate this quantity not in O of n like we are doing here, but in O of 1. Like, just iterate over from 0 to n minus 2, and you can calculate this quantity in O of 1 only. And how do you do that? You can do that using just, it is given the question itself. In the question, like, they have defined prefix sum and suffix minimum. So you can simply maintain these arrays. Like, just make an array for prefix sum. Okay, let's call it PS. So maintain an array called PS, where PS of I is just the sum of array 0 to array I, A0 to AI, right? And also maintain an array called suffix minimum. So let's say SM. So SM of I is defined as A of I plus 1 up to, minimum of A of I plus 1. Minimum of A of I plus 1 up to A of n minus 1, right? So you can simply make these two arrays by using the prefix sum idea, right? Like, to calculate the prefix sums, you can simply do PS of I equals to PS of I minus 1 plus A of I, right? You can simply do this for I equal to 0 to n minus 1. And similarly for suffix maximum, you can simply do SM of I is equal to min of SM of I plus 1, right? And since this I plus 1, like, SM of I plus 1 has the elements from AI plus 2 up to AN minus 1, right? So now you want to include A of I plus 1. So you will do min of SM I plus 1 comma A of I plus 1. Okay, so you can just calculate these two arrays beforehand. Like, before you iterate from I is equal to 0 to n minus 2, before you do this, you can simply calculate these two arrays, and then you can find out the answer. Like, then you can simply run a for loop from I is equal to 0 to n minus 2, and just the quantity is PS of I minus SM of I. So you can simply run this for loop, and this is just O of 1, right? So this will take O of 1 amount of time, like this quantity, and so this is in a for loop. So this will entirely this will take O of n time, right? TC is O of n, and space complexity also is O of n, right? But here, if we had done this one, then the space taken is O of 1, extra space is O of 1, but time is O of n square. So it's a, like, trade-off, right? So yeah, that is the thing. You can see, I'll show the code also. So here's the code. I'll show it. I'll zoom in a little bit. Yeah, so this is the code. I guess it is not zoomed in, so I will copy it in VS Code. Yeah, this is the code, and So int n equals to nums dot size. Okay, I am making these two arrays, prefix sum and suffix minimum. So suffix minimum last element is nums dot back, right? And prefix sum of 0 is nums of 0. Initialize both the values, and in this for loop we can initialize prefix sum of I. So prefix sum of I is equal to prefix sum of I minus 1 plus nums of I. Okay, and in this for loop we'll do suffix minimum of I is equal to min of sm of I plus 1 comma nums of I plus 1. Okay, and then finally we can iterate from I equal to 0 to n minus 1, and we can do ans equals to max of ans comma psi minus smi, and then return the answer. Okay, this was the problem number A. So let's move on to B now. So B is this. Basically B is called minimum cost to acquire required items. You are given 5 integers, cost 1, cost 2, cost both, need 1 and need 2. There are 3 types of items available. An item of type 1 costs cost 1 and contributes 1 unit to the type 1 requirement only. Item of type 2 costs cost 2 and contributes 1 unit to the type 2 requirement only. And an item of type 3 cost both and contributes 1 unit to both type 1 and type 2 requirements. You must collect enough items so that the total contribution towards type 1 is at least need 1 and total contribution towards type 2 is at least need 2. So what is the minimum cost that they're asking? Okay, so this is a pretty simple problem. Like basically you have an item, like you have items of 2 types. Okay, so you have an item of type 1, right? I'll just use white pen. Okay, so you have an item of type 1 and item of type 2, right? If you want to buy only item 1, then it will cost you C1 coins, and if you buy only type 2, it will cost you C2 coins. And if you want to buy both, then you can buy both at a cost of C3, right? So they have given this C1, C2, C3, and what we have to do is we have to buy at least n1 items of the first type and at least n2 items of second type, right? Okay, so what is the minimum required cost? Like what is the minimum possible cost that you can have? Okay, like basically at least n1 and n2. You can have more than that also. Like if you want, then you can have more than these quantities. There is no problem. So let's take an example. Like here test cases are given, so we will just take an example. Let's say C1 is 5, C2 is 4, C1 is 5, C2 is 4, C3 is 15, right? And N1 is 2, N2 is 3. Okay, so first of all, for this test case, you can observe that if we want to buy both of them, then we can pay either 15. Like there is one option that we can pay 15 and get both of them, 1 and 1 quantity of both. Or actually if you just buy them individually, like just buy a type 1 element for 5 and buy a type 2 for 4. So that is better, right? Why would you buy for this? Because 5 plus 4 is 9. So by giving 9 coins, you are getting the same amount, like you are getting the same thing, 1 and 1 for 15 also. So like if you pay 15 also, then also you get 1 and 1. So of course you will pay 9 only, right? So if this C1 plus C2, like basically this C3 is useless, this C3 is useless if your C1 plus C2 is less than C3, right? Or even if it is equal to C3, then also it is useless. Like we can simply buy both of these and it will give same cost, right? So if my C1 plus C2 is less than equal to C3, then C3 is useless. We will never buy 2 items simultaneously. We will only buy using C1 and C2, right? And so if we want n1 items of the first type and n2 of second type, and C1 only gives the first type and C2 only gives second type, so of course we will have to buy the first item n1 times and original cost C1, so N1 into C1 plus N2 into C2, right? So this is the cost, the minimum cost if C3 is useless. Like basically in this case, if C3 is greater than equal to C1 plus C2, then it is never optimal to buy C3, because instead of C3 we can simply buy a C1 and a C2, right? So if this is the case, then this is the answer, because if we only want to buy C1 and C2, then of course we will buy N1 items of C1 and N2 items of C2, right? So this is the case 1. But now case 2 is where C3 is useful. C3 is useful. So like basically the cost of buying via C3 is less than C1 plus C2. Okay, so let's just change this test case. Like let's say here, okay, let's just select this and paste it right here, and let's say the cost C3 now has become something less than 9, let's say 7. Okay, so C1 is 5, C2 is 4, and C3 is 7. So now the thing is that if you want to buy both of them, if you want to buy one and one quantity of both, then either you can buy them separately, 5 plus 4, or you can buy them at a cost of 7. So of course you will buy at 7 cost, right? So you will buy at 7 cost. So now you want to buy 2 elements of N1 type, I mean type 1, and 3 elements of type 2. So basically what you can simply do is you can buy 2 comma 2, like you can buy them in a pair 2 times, like just pay the cost C3 2 times, right? And then what you will need once more is this N2, right? Like basically what I'm saying is, if you want 2 items of type 1 and 3 of type 2, then you can simply buy the pair option 2 times, which will give you 2 elements of type 1 and 2 of type 2. So now you are left with 1 element of type 3, I mean 1 element of type 2, right? And you want to buy that. Okay, so you can simply spend C2 items to buy that item. Okay, so 1 element of type 2 you can buy using 4 coins. Okay, so here you spend 7 into 2, and here you spend 4, so this gives you 18 coins. Okay, so that's the main strategy, that you can simply okay, if the C1 plus C2 is less than equal to C3, then the answer is N1 C1 or N2 C2. But if it is less than, like if C3 is useful, then we will use it. Okay, like whatever is the minimum of N1 and N2, we will buy that many pairs, right? Like if N1 is 100 and N2 is 500, then we can buy 100 pairs. So in general we can say that we can buy minimum of N1 comma N2 pairs, right? And it will cost us min of N1 comma N2 into C3, right? And then whichever one is left, we can simply buy that. Like here in this case, if 400 and like type 2 of 400 are left, so we will do 400 into C2. But actually there is one more edge case here. That what if this C3 somehow costs less than C2 as well? Like basically, what if C1 is let's say 4, C2 is 5, and C3 is 4, and you want to buy 100 items of type 1 and 200 items of type 2, right? So what you will do is you will first buy like 100 pairs. Okay, so 100 into 4. So now you want, okay, so now you have what, 100 pairs, so you have 100 each of N1 and N2, but you need 100 more of type 2, right? So what I told you is just buy 100 of type 2, so 100 into 5, like 100 into C2. But actually what you could have done is that because C3 was less than C2, you can simply buy 100 of like again 100 more pairs you can buy. So instead of 100 into 5, it becomes 100 into 4, right? So like you can do this. This is better. Okay. So the strategy now becomes that first by minimum of n1 comma n2 pairs, n1 comma n2 pairs for cos C3, and then let's say if type 2 is remaining, then by like n2 minus min of n1 n2 for cost C2, like either C2 or C3, like if C3 is smaller than C3, so minimum of C2 comma C3, basically minimum of C2 comma C3, right? So like I'm assuming that if type 2 is remaining, then you can buy n2 minus like whatever is the remaining. You have bought this many, right? You have bought these many, so n2 minus this much is left, and you can buy that at a cost of min of C2 comma C3. If C3 is smaller, then you will get some n1 also, like some type 1 also you will get, but that is fine because you need to have at least n1 n2, right? You need to have at least n1 n2 quantities of both, not exactly, so you can buy extra as well. Okay, so finally the answer becomes that if your C3 is greater than equal to C1 plus C2, then the answer is n1 C1 plus n2 C2. And if your C3 is less than equal to, I mean if it is less than C1 plus C2, then your answer becomes basically C3 into min of n1 comma n2, and let's say this min value is m. Okay, I'll call this m. So I have purchased m items of both types. So for type 1 I still have to purchase n1 minus m at a cost of C1, or actually min of C1 comma C3, min of C1 comma C3, and for type 2 I have to purchase n2 minus m into min of C2 comma C3, right? So this is the answer. And actually like either this term or this term will be 0, like depending upon which one is lower, n1 or n2. Like if n1 is lower, then the minimum will be n1, right? So m will equal to n1, and so this term will be equal to 0 because you don't need to buy any type 1 quantities, right? So automatically it will become 0 and this will be non-zero, right? So it works out. So this formula is correct. Okay, so this is the answer. If C1 is greater than equal to C1 plus C2, if C3 is greater than equal to C1 plus C2, then this is the answer, and if it is less than that, then this is the answer. Okay, so that's what I have written in the code. First of all, I have just typecasted into long so that I don't have to, so that like multiplication does not overflow. Okay, so I have just copied these variables into a long variable, and if C1 plus C2 is less than equal to CB, then return n1 C1 into C2. Otherwise, return CB into min of n1 n2 plus min of C1 C3 into n1 minus min of n1 n2 plus min of C2 C3 into n2 minus min of n1 n2. So this is the exact same thing I have written on the whiteboard, right? Okay, so let's move ahead to the next problem now. Problem number 3, sorry. Okay, so this problem is called smallest all ones multiple. You are given a positive integer k. Find the smallest integer n divisible by k that consists only the digit 1 in its representation. Okay, return an integer denoting the number of digits in the decimal representation of n. If no such n exists, then return -1. Okay, so what they are saying is we have been given an integer k. Okay, we want to find out the smallest possible n, smallest possible n, such that it is of the form 1 1 1 1 1 1 1 1, like 1 1 repeated d times. Okay, so we want to find out that the smallest possible number n, which is 1 repeated any number of times, that is either 1 or 11 or 111 or 1111 and so on. We want to find out the smallest possible number which is a multiple of k. Okay, like basically the remainder of n modulus k should be equal to 0. So we want to find out what is the smallest possible value of n, and if there is no value, then we have to return minus 1. Like we have been given this k and we have to determine that what is the smallest possible value of n. Okay, so how do we actually do this? Like essentially what we want to do is we want to find out the smallest d such that this number 1111 up to 11, this d times this should be multiple of k. This should be a multiple of k, right? So like how do we determine that what is the value of d? So actually this is a kind of mathematical problem. Okay, like because you can't really try every mod. Like let's say you just try to do brute force, like you try 1, then is 1 a multiple of k? If it is, then print it, otherwise no. Then you try 11, is 11 a multiple of k? We don't know, like it might be or it might not be. Then is 111 a multiple of k? So if you keep checking like this, if you like just keep checking like this, then there are two issues with this. First issue is, then when will you stop? When do you stop? Because like we don't know that what if it doesn't exist? Like what if for a certain k the answer is -1? So this will run infinitely, right? And the second issue is that as soon as you hit like many number of ones, like as soon as you hit 60 ones, let's say, or not even 60, let's say 20 ones you hit. Okay, so it will be approximately 10 to the power 20 or 10 to the power, okay, let's say if you hit 21 ones, okay, so it will be 10 to the power 20, and this is out of the range of long, right? This is not inside the range of long, so you cannot really check any numbers which are greater than 10 to the power 20. So you have to stop there. Like, but it might be possible that what if a bigger number is a multiple of k, right? Like in the samples they have given. Okay, so there is not any sample which is having a high answer, but still there might be some k, there might be some possible k for which the answer is a very big, like maybe 21 ones, 21 times. So this does not even store in long. So you cannot even check that this number is a multiple of k or not, right? So the brute force approach has these two problems, right? Like you cannot just do it naively, all right? You have to think of some other patterns. Okay, that is the issue in this problem. All right, so let me reiterate the problem. You have to find n which is 1111 repeated d times, okay, such that this is a multiple of k. So basically we want that n mod k, that is remainder of n when divided by k, is equal to 0. Okay, now what I am saying is, what if we would try to write this n in terms of some expression? Like this 1111 d times is not very helpful, so let's try to make it kind of helpful to us. Okay, so you can write this number as unit digit 1 plus 10 digit is 10 to the power 1 plus 10 to the power 2 plus 10 to the power 3 up to 10 to the power d minus 1, right? So this is a GP. Okay, this is a GP of having common ratio equals to 10 and number of terms equals to d and starting term is equal to 1. So if you apply the formula for the sum of GP, that is a into r to the power number of terms minus 1 upon r minus 1. So this will turn out to be 1 into 10 to the power d minus 1 upon 10 minus 1, which is 9. So basically you have 10 to the power d minus 1 divided by 9. Okay, so this number, like 1111 repeated d times, is the same as 10 to the power d minus 1 divided by 9, right? So we want that this number n, which is 10 to the power d minus 1 divided by 9, this number has to be divisible, like mod k should be equal to 0. Okay, so we want that this number, which is 10 to the power d minus 1 divided by 9, has to be divisible by k, that is its remainder mod k should be equal to 0. Or we can say that 10 to the power d minus 1 divided by 9 has k as a factor, right? Factor. Okay, so what does that mean? That means that this number 10 to the power d minus 1, 10 to the power d minus 1 has 9k as a factor. Has 9k as a factor? No? Can't you see this? Like, if this 10 to the power d minus 1 upon 9 has k as a factor, then basically, like, let's say this is capital N. So n upon 9, capital N upon 9 has k as a factor. So if you think about it, capital N must have 9k as a factor, so that when you divide by 9 also, because 9 goes away, but still k is there. K is still there, right? So capital N must be a multiple of 9k. Okay, so basically 10 to the power d minus 1 has 9k as a factor. What? So that means that the remainder, if I divide by 9k, must be 0. So like 10 to the power d minus 1 modulus with 9k must be equal to 0, right? So we can say that the 10 to the power d, if I like modulus with 9k, must be equal to 1, right? This is the condition, that we want such a d, we want a d such that 10 to the power d modulus 9k should be equal to 1, right? This is the entire condition. So we can simply try d, like again, like now the problem 2 is eliminated. Like what I was saying is, the problem 2 was that our numbers were becoming too big. Like if we just see that 1111 21 times, that will still not fit in the long range, right? So what we have done is, we have simplified the expression, and we have found out that 10 to the power d modulus 9k should be equal to 1. That is the condition. So we have to find such a d. Now what we can simply do is, we can iterate from d is equal to 1 to, like, okay, let's say we iterate from d equal to 1 and onwards, and we keep incrementing d, and we can simply find 10 to the power d modulus with 9k. Like see, in the some PNC problems or in DV problems, they tell you, right? They tell you to find the answer modulus 10 to the power 9 plus 7, right? They tell you like this. So so like that's how you can take the mod at every step and find the answer. So here also we just need to find the value of 10 to the power d modulo 9k, right? And we can simply do that. Like we can simply iterate from d equal to 1 and onwards, and we can like find out the value of 10 to the power d by taking mod with the 9k every time. And if it becomes equal to 1 at any point, then we return that d. Okay, so like for example, we have k equal to 7, right? If we have k equal to 7, that means we want that 10 to the power d has to be a like 10 to the power d minus 1 upon 9 has to be a multiple of 7. So 10 to the power d minus 1 has to be a multiple of 63. So 10 to the power d modulus 63 should be equal to 1. So like let's try for d equal to 1. if d is equal to 1, then 10 to the power d is just 10, and if I take mod also, it remains 10, so it is not 1, right? Then for d equal to 2, it is 100, and mod 63 is 37, so it is not 1. Then for d is equal to 3, we can multiply this 37 by 10, so it becomes 370. But 370 mod 63 is what? Let me use Python for that. 370 mod 63, 55. Okay, so it becomes 55, and it is still not 1. Then for d equal to 4, it is 550, and if we take mod with 63, so 550 mod 63 is 46, still not 1. Then 460 mod 63, 19, and 19 mod 63 becomes 1, right? So basically at d equal to 7, your 10 to the power d, basically I can show you, like 10 to the power 7, 1 2 3 4 5 6 7, if you take mod with 63, sorry, not 7, 6, the answer is 6. Okay, so d equal to 6, if you take 10 to the power 6 modulus 63, that is 9k, you will get 1. Okay, 1 2 3 4 5 6 mod 63 is 1, right? So we can say that 1 1 1 1 1 1 6 times is a multiple of 7, right? That is the condition. So finally the condition is just that 10 to the power d modulus 9k must be equal to 1. So like our mod is 9k, and we have to find out the value of 10 to the power d modulus 9k, and just find out the value, which is 1, right? But now the problem is still there, a problem that when do we stop? Like how do we know if it exists or not? Like how do we know if a number such that 10 to the power d is 1 exists or not, a number d? Like when do we stop? That is still the problem. So the point is that if you take mod, then eventually a cycle will be there. Okay, like for example, if my mod is 7, let's say, if my mod is 7, let's say I am trying to find out 10 to the power d values mod 7. So first of all, for d equal to 1, it becomes 10 mod 7, which is 3. Then we can, like if we want to find 10 to the power 2, like if you want to find 10 to the power 2, we can multiply 10 to the power 1 by 10. So this is 10 to the power 1, right? And we can multiply by 10, so to get 30, and 30 mod 7 is 2. Then we can multiply this 2 by 10 to get 20, and 20 mod 7 is 6. Then 60 mod 7 is 4, and 40 mod 7 is 5, and 50 mod 7 is 1, and 10 mod 7 is 3, right? So we got to 3 again, and now you will notice that 3 has already occurred before, like 3 already has come before. So again, if we multiply by 10, we will get the same sequence, 3 2 6 4 5 1. Okay, so the point is that as soon as a number repeats, like this 10 to the power 1 is 3, 10 to the power 2 is 2, 10 to the power 3 is 6, 10 to the power 4 is 4, and 10 to the power 5 is 5, 10 to the power 6 is 1, and 10 to the power 7 is again 3. So my point is that as soon as this number repeats, we can stop checking at that. Like if until here we did not get anything, then आगे भी नहीं मिल पाएगा. Like इसके बाद we only have the pattern repeating, right? So if we did not find the number here, we will not find it anywhere else. Okay, and the thing is that this pattern will repeat after at most 9k. Like if we are doing 10 to the power d modulo some m, right? So this can have at most m minus 1 or m values, right? Like it can have either 0 1 2 or up to m minus 1, right? Like 10 to the power d, the remainder with m can be either 0 1 2 or up to m minus 1. So this quantity can have only m minus 1 distinct values or m distinct values, right? So if we find out like m times 10 to the power d, like we find 10 to the power 1, 10 to the power 1, 10 to the power 2, 10 to the power 3, and so on. If we find out up till m, 10 to the power m, then definitely we will have gotten our number in this series, because after this definitely at least one number will repeat. Like if we find out 10 to the power m plus 1, it will be same as any of some of the numbers before that. Okay, so we only need to check till 10 to the power m, and here in our case m is 9k, right? We will find the value of 10 to the power d modulus 9k. So we will just iterate from d equal to 1 to 9k, right? And if we do not find any value which is equal to 1, then we can say that the answer is -1, and otherwise we will just print the d. Okay, so the code is simply like this: long p equal to 1. So I am storing the value of 10 to the power d in this. So initially it is 1, and I'll iterate from int I equal to 1, I less than equal to 9k, I plus plus, and p is equal to p into 10 modulus m, right? So basically if I is there, like if this for loop current value is I, then this p variable stores 10 to the power I modulus 9k. So if that is equal to 1, then we can return that I, right? And if we do not find a 1, if we do not find a 1 until the m value, then we will know that we will not find a 1 after that, right? So we'll return -1. We'll return -1. Okay, that's a solution. All right. So I hope you guys understood this, and if you didn't, then you can comment down below, and I'll reply to your comment hopefully. Okay. So let's move on to the next problem, which is the last one of today. That is number of balanced integers in a range. So like I know the problem actually, so I'll just tell the problem while it is loading. Okay, so the problem was that you have, like you can define a number n. Let's say there's a number n. Let's say 1, 3, 2, 4. Okay, then this n is called balanced. N is called balanced if the sum of odd positions, sum of odd digits, I mean sum of digits at odd positions is equal to sum of digits at even positions. Okay, like here if I index it 0, 1, 2, 3, so the even position are this one and odd are this ones. So sum at even turns out to be 1 plus 2, which is 3, and sum at odd is 3 plus 4, which is 7, right? So this n is not balanced. Okay, so they have defined that for a number to be balanced, the sum of odd digits or sum of digits at odd positions should be equal to the sum of digits at even positions. Okay, so we have to find out that in the given range L to R, like they have given us a range L and R, and in this range from L to R inclusive, we have to find out that how many numbers I are there which are balanced. Count the number of balanced integers. Count the number of balanced integers between L to R. Okay, that is the problem, and yeah, that is the problem, and the constraints on L and R are pretty big, right? Until 10 to the power 15. So L and R are up to 10 to the power 15. Okay, so we have to find out that what is the number of balanced integers between this range. Now to solve this, the first thing is that whenever you want to find out the number of elements in a range L to R, it is a very common trick that you can simply find out the number of elements in the range 0 to R, and from that subtract the number of elements in the range 0 to L minus 1. Right? Like you can simply find out the answer for 0 to R, that in 0 to R how many numbers are there which are balanced, and from that you can subtract that in this range till L minus 1 how many numbers are balanced. So you will find out the answer for L to R, right? It's pretty obvious. Like let's say if these numbers are balanced, these 5 numbers, and my L is this and my R is this. So if you want to find out in this range, then you can find out in this total range, and you can subtract this range from it. So you will get this range, right? So basically your problem boils down to you need to find out the answer for 0 to R, because like if you write a function, you can simply write a function which takes in an integer R and returns the answer for 0 to R, right? And then you can simply call that function for R, and you can minus function for L minus 1, right? You can do this. This is your final answer, right? So now you just need to find out that what is the function, like how do you write the function which finds the answer for 0 to R. So the problem is boiled down to find number of balanced numbers in the range 0 to R. Okay, so basically number of balanced numbers less than equal to R, right? The number of balanced numbers less than equal to R. Okay, and balanced means what? Balanced means that the sum of odd positions should be equal to the sum of even positions. Okay, so now what can we do? Now let's try to solve a problem which is its easier version. Like this problem is pretty hard, like not very hard, but it is slightly hard. So instead of that, we can solve an easier version first. So let's say that we want to find out the number of 5 digit or less than equal to 5 digits, balanced numbers. Okay, so like what I am saying is I want my number to have less than equal to 5 digits and it has to be balanced. Okay, that is my condition. So how do we count that? Like let's say basically I want to have 5 digits, right? So 1 2 3 4 5 blanks, and I can fill anything. Like I can fill anything in these blanks from 0 to 9, right? And it will still remain 5 digit. Okay, so let's say I fill x1 here. Let's say the number is x1, x2, x3, x4 and x5. So I want that all my xi's are between 0 to 9, right? And I also want that my even position, like sum of even, is same as sum of odd. So my x2 plus x4 should be equal to x1 plus x3 plus x5. Okay, and my range is between 0 to 9. So I have to count all the 5 tuples x1, x2, x3, x4, x5 such that this holds. I mean these two conditions hold, right? So basically I want this thing only, right? That my xi can be from 0 to 9 and the sum of like x2 and x4 should be equal to sum of x1 plus x3 plus x5. Okay, so how do we actually solve this? That's the question. So actually it is very simple to solve this. Just hear me out. Okay, so since xi are limited up to 9 only, like since the range of xi is from 0 to 9, right? So the maximum value that can be here, like on this LHS, this left hand side, this can take a maximum value of 18, right? Like if we put both 9 and 9, it can be 18, right? So my point is that this entire thing, like this LHS equal to RHS we want, right? So both sides will be at most 18. So the sum will be at most 18, like it can be anything from 0 to 18. Okay. So my idea is that, let's say we just find out, like let's just keep it as k, like just keep this as some k, and let's find out that what are the number of tuples for this to be equal to k. Like let's say if I want k equal to 1, for k equal to 1, what are the number of possibilities such that this sum is equal to 1, right? So for the LHS, like I want x2 plus x4 to be equal to 1, right? So basically what are the conditions? Like either 0 comma 1 or 1 comma 0, right? And on the RHS also I have x1 plus x3 plus x5 to be equal to 1. So either I have 0 0 1 or 0 1 0 or 1 0 0, right? So these three are the possibilities. So for x2 and x4 I have these two possibilities, and for x1 x3 x5 I have these three possibilities, and I can take any two of them. Like from these two I can take any one, and from these three I can take any one, and I combine them. Like if I take 0 1 and I take 0 0 1, so basically if I combine these, like if my x2 x4 is 0 1 and x1 x3 x5 is 0 0 1, then my x1 x2 x3 x4 x5 is what? x1 x2 x3 x4 x5 becomes like 0, then this 0, this 0, and this 1, and this 1, right? So this is one possible tuple for sum equals to 1. So since I have two possibilities on, like for this side and 3 for this side, so total answer is 6. Like there are total 6 ways in which I can make my x2 plus x4 and this equal to 1, right? So for k equal to 1, the number of possible numbers is 6. Okay, so the number of balanced numbers with sum equals to 1 is 6. So basically we just need to find out, like if we want to solve this problem, that how many numbers are there, like how many 5-digit numbers are there which are balanced. So to solve that, I just need to find out that in how many ways can I break this thing. Like for k I need to solve, basically the thing is that I want to have this, right, that x2 plus x4 is equal to x1 plus x3 plus x5, which is equal to k, right? So let's say for a certain k, this has a solutions and this has b solutions, then total number of numbers for this k value is a into b, right? But now how do I find out the a and b values? That is the question. Okay, so the question is that basically I can have my xi values, like suppose I am solving this. Okay, x1 plus x3 plus x5 is equal to k, and I want to find out that if my xi has to be between 0 to 9, 0 less than equal to x1 less than equal xi less than equal to 9. If I want this range for my xi, then in how many ways can I break k? Okay, that is my question. Like in how many ordered ways can I break this k into 3 numbers such that all of those 3 numbers are between 0 to 9, right? So this problem is a very general problem, right? Like this problem is very standard problem in DP. Like you can simply use DP to solve this, and it is on CSES as well. CSES, it is called coin combinations 1. Coin combinations. Okay. Like I'll show you this. So on CSCS you can see this DP, this coin combination is 1. This problem is what we want to solve, right? So like, okay, this is kind of different. Yeah, dice combinations you can say, or okay, I'll just teach this, that basically I want to find out the number of ways to break k into 3 numbers, right, such that all are between 0 to 9, right? This is our problem that we need to solve. So actually we can recursively write this problem. Like let's say that I want to find out that, let's say I want to break this k into 3 numbers which are all between 0 to 9. Okay, so now tell me, the last number can be what? It can be 0, it can be 1, or it can be 2, or it can be 3, and so on. So let's say if the last number is 0, then I want that these two ka sum should be equal to k, right? Okay, then if this is 1, then the sum of these two should be k minus 1, right? And if this is 2, it should be k minus 2. So basically the answer for k comma 3 is basically the answer for k comma 2 if I keep 0 here, plus the answer for k minus 1 comma 2 plus the answer for k minus 2 comma 2 up till answer of k minus 9 comma 2. Like this is simple DP, right? That DP of ij I define as in how many ways can I make sum equals to j using I variables, using I numbers from 0 to 9, right? This is my dpij, and I can simply calculate that using the recursion that I gave above, right? Like basically if I want that the sum of these three numbers should be equal to 13, let's say, then either I can keep 0 here, so I can have 13 sum for these two, or I can have 1 here and I can have 12 sum for these two. So the number of ways I need for these two, right? So like this is the recursion, that the answer for k comma 3 is basically the answer for k comma 2 plus the answer for k minus 1 comma 2 plus k minus 2 comma 2 and so on. So like you can simply fix the last number and recursively find out the answer. Okay, so my dpij is basically the sum of k is equal to 0 to 9 dp of I minus 1 comma j minus k, right? So dpij is this. Okay, so you can just calculate this dp beforehand. Okay, so now like basically what you know is dpij, which is the number of ways to break j into I parts, number of different ways, right? You know this quantity now. So now if you want to find out the number of 5-digit numbers, such that it is balanced, okay, so x1, x2, x3, x4 and x5. So let's say you want this to be balanced, so that means you want this to be x2 plus x4 should be equal to x1 plus x3 plus x5, and if it is equal to k, then you can say that like you can simply find out the combinations. Like basically the answer for x2 plus x4 equal to k, like the number of ways or the number of tuples that x2 plus x4 can be equal to k is basically dp of 2 comma k, right? Like the number of ways to break k into two parts. And for this side, the answer is dp of 3 comma k, right? And so your final answer is dp of 2 comma k, dp of 2 comma k into dp of 3 comma k, right? This is your answer for some k, and you can just take this sum for k equal to 0 to k equal to 18, right? And that will give final answer. That will give you the number of 5-digit numbers which are balanced, right? Like the entire idea here was that if you want odd sum equal to even sum, then you can simply iterate over that sum. Like if you want it to be some k, then you can find out that what is the range of k, and for each value of k you can find out the number of combinations that you can break it into, and that is just a dp, that is just it's a simple dp problem. Okay, so that's how you can solve the easier version of this problem. That is, just find out find out the number of 5-digit balanced numbers, or less than equal to 5 digits, because they can be 0 as well, right? x1 can be 0, x2 can be 0, so in that case they will be less than 5 digit. But anyways, that's how you can find out this answer. But now what is the problem? Like the problem right now is that we have to find the range 0 to r. Like we have to find the answer in the range 0 to r. That is our number that we make here. Let's say, suppose this r is 6 digit. Okay, this r is 6 digit number, right? So my number would look like x1, x2, x3, x4, x5 and x6, right? So of course I will have only 6 digits because r is 6 digit, because if I have 7 digits then it will be definitely greater than r. Okay, so I want that this number must be less than equal to r. I want that, right? Like I want to count the number of numbers such that it is less than equal to r, and I also want that x1 plus x3 plus x5 should be equal to x2 plus x4 plus x6. Okay, so let's say I am counting for k. Let's say it is equal to k, so I will count for some equal to k, and I will iterate from k equal to 0 to 27, because there are 3 variables and the maximum value is 9, so at max it can reach 27, right? So I will check the answer for all values of k. I will check the answer for all values of k from 0 to 27. Okay, but I also want that like this number that is formed has to be less than equal to r. So now how do I take care of that? That is the entire issue now, because in the above case, when we had that we need to have at max 5 digits, so in that case all 5-digit numbers worked. Like whatever value these takes, like whatever value this x1, x2, x1, x2, x3 takes, that is fine, because we just need to have, like we had a condition that it had to be less than equal to 5 digits. But right now the condition is that this number must be less than equal to r, right? So how do we solve that? So my point is that, okay, if this number is less than equal to r, or let's say it should be less than r, like let's just assume for now that our number is less than r. Okay, so for this number to be less than r, it has to be that at some digit, like let's say this my number is x1 to x6 and r is like some r1 to r6. Okay, so r1, r2, r2, r3, r4, r5 and r6, right? So if I want that this number is smaller than this number, then basically at the first place where they change, like at the first position where they are different, this r3 has to be greater than x3. Like let's say if r1, x1 are same, r2, x2 are same, and they are different, then x3 has to be less than r3. Okay, and then we can have anything here, like then these three numbers can take anything. Okay, so using this fact we can actually count easily. Like let's say my r is 2 3 4 6. Okay, so I want 4-digit numbers, right? x1, x2, x3 and x4. Okay, so first of all what I can do is, let us take x1 equals to 0. Okay, so if I take x1 equal to 0, then I can keep anything here. Like if I take x1 equal to 0, then I can take anything here, and this entire number will still be less than this, right? So I can find out the answer for this, that if I want x3 plus 0 equal to x2 plus x4 equal to some k, then I can find the number of pairs using the above method, right? And all those numbers would be less than this number, so I'll add it to my answer. Then what if I take 1 here? If I take 1 here, then basically I want that x3 plus 1 should be equal to x plus x4, which is equal to k. So basically I want that x3 should be equal to k minus 1 and x2 plus x4 should be equal to k. So I can still find the number of solutions for this using my dp, right? Like this is basically dp of 1 comma k minus 1 into dp of 2 comma k, right? So if I and still, like if I have 1 here, then of course this number will still be less than this r, right? So I can add it to my answer. Like I just put 0 here first, I added it to my answer, and then I put 1 here, and again I add it to my answer. And then what if I keep 2 here? So if I have 2 here, then I can't say that whatever answers I get for this, like I want x3 plus 2 is equal to x plus x4. So whatever answer I get for this, it might happen that it becomes greater than r, right? Because let's say if it comes to be 4 6 0, okay, so I mean 4 6 4, right? So this is greater than 2 3 4 6, it is not in the range, so we cannot do that. So like basically we can keep either 0 here and count the number of possibilities, or we can keep 1 here and count the possibilities. And then what we can do is we can keep 2 here and go to this index. Like then here we will keep 0 and then count for these two. Like we will count that 2 plus x3 equal to this plus x4. We'll count the answer for this one, and they'll always be less than that. Then we will keep 1 here. We'll keep 1 here and count for this, like 2 plus x3 equals to 1 plus x4. Then we will keep a 2 here and then count the answer and add it to our answer. And then we'll keep a 3 here, but we cannot add the answer now, so we will keep a 0 here, then a 1 here, then a 2 here, then a 3 here. So in this way we can simply iterate over all the indices, and like basically if I'm at this index I, if I'm at index I, then all of the numbers before I have been fixed now. Okay, and after that we are calculating the number of possibilities such that odd becomes equal to even. Okay, like if I give one more example, let's say I have 216804. 216804, this is my r, and I want to find solutions. So either I'll have a 0 here, right? So if I have a 0 here, basically I want that 0 plus, okay, I'll keep x2 x3 x4 x5 x6. So I want 0 plus x3 plus x5 should be equal to x2 plus x4 plus x6 should be equal to k. So I'll iterate on this k. I will iterate on this k from 0 to 27 or 0 to 18. So like I want that x3 plus x5 should be equal to k, and x2 plus x4 plus x6 should also be equal to k. So now the answer for this is basically dp of 2 comma k. and the answer for this is dp of 3 comma k, right? And we will multiply them to get a final answer. That is, if we keep here 0, if we keep 1 here, then we want that 1 plus this should be equal to these plus, like these three sum should be equal to k. So basically we want that x3 plus x5 should be equal to k minus 1, and for that the answer is dp of 2 comma k minus 1, right? And for this the answer is dp of 3 comma k. So we can multiply them and we'll find the answer for if we have 1 here, and then if we have 2 here we can't directly do it, so we'll keep 2 here, then we'll keep 0. So I want that 2 plus x3 plus x5 should be equal to 0 plus x3 plus x4 plus x6. Sorry, 2 plus x3 plus x5 should be equal to 0 plus x2 plus x6. And let's say if it is equal to k, then basically 2 plus x3 plus x5 should be equal to k. So which means that x3 plus x5 should be equal to k minus 2, and x4 plus x6 should be equal to k, right? So the answer for this would be dp of 2 comma k minus 2, and for this it would be dp of 2 comma k, and we can multiply that and find the answer for these numbers. And then similarly we can keep 1 here, then we'll start with 0, then 1 up till 5, and then we keep 6 here, then we start with 0, and so on. Like that is what we can do. Basically I want to calculate the answers, like I want to find out the numbers less than equal to r, right? Like let's say if r is 216804, so first I am counting the numbers of the form 0 something, like 0 and then 5 blanks, then I am counting 1 and then 5 blanks, then I am counting 2 0 and then 5 blanks, or I mean 4 blanks, then I am counting 2 1 0, then I am counting 2 1 1. So all of these numbers are less than this number, right? So I am finding the answer for this, the answer for this, the answer for this, and so on, and that can be found easily by dp, right? And so this will run for, like basically these are number of digits into 9, right? And for each type of configuration I am iterating over the value of k, right? The value of k also I am iterating, which is from 0 to like number of digits into 9, right? So my complexity just turns out to be 81 into number of digits, 81 into number of digits ka square, right? Digit into 9 into digit into 9. Like if I basically what we are doing is we are finding the answer for starting with 0, then starting with 1, then starting with 2 0, starting with 2 1 0, 2 1 1. So these can be at most 9 into number of digits, right? So that is what we have. And to find the answer for one of these possibilities, we are like varying k from 0 to something, right? 0 to maximum sum possible. So maximum possible sum is digit into 9, and actually by 2, like because we want that even should be equal to odd. Like see, if I have let's say an 8-digit number, if I have an 8-digit number which is balanced, and I want that even sum should be equal to the odd sum should be equal to k, then basically what is the maximum? Maximum I can get is 9999999, right? So in that case the sum would be 36. 36 and 36 would be equal, right? So maximum sum that I can get is number of digits into 9 upon 2. So I will vary k from this to this and then find the answer for that. So for each of these type of numbers, I am looping from 0 to this by 2. So my final complexity turns out to be O of 9 into digit into 9 into digit by 2. Okay, so this is basically O of 81 into digit square by 2. Alright, like number of digits ka square. And since the number of digits are very less, this works. Alright, so I'll show the code now. I will copy it to my VS Code. Okay, so in this function count balanced, first I just find out the dp values. Like my dpij is basically um, the number of ways to make sum j using I variables, right? So the number of ordered ways to make sum j using I variables. So um, they can be from 1 to 8. So for int I equal to 1, I is equal to I plus plus. So like for int I from 1 to 8 and j from 0 to 72, I am finding out dpij. So um, like basically this k goes from 0 to 9, and it takes that, like it says that what is the last value. So the last value is k, then I want dp of I minus 1 comma j minus k, right? So dp of I comma j plus equals to dp of I minus 1 comma j minus k, and initially they are 0. Initially all of them are 0, and only 0 0 is 1. Like I can make a sum of 0 using 0 variables, and there's only one way to do that, right? So this is how the dp works, and then I return the func of high minus func of low minus 1, right? And how does func work? Basically I just convert it to a string first. This variable I convert to a string, and then what I have is I am maintaining two variables called odd sum and even sum, which is that on odd positions how much I have already fixed. Like let's say when I'm trying to find the answer for this thing, let's say if my r is 216804 and I am at this index. Okay, so like let's say I am finding out the answer for 2166 dash dash, right? So already I have reached the sum 2 plus 6 8 on the odd indices and 1 plus 6 7 on the even indices. So I am storing that how much sum do I already have, right? So when I am iterating on k, like when I want that total even sum should be equal to total odd sum should be equal to k, right? So what I want is that the remaining elements should give k minus even sum. Like the remaining even elements should give k minus even sum, where even sum is until now how much I have done. So let's say 8, so k minus 8, and the rest of the odd elements should give k minus 7 sum. So I will just call the dp for k minus 8 and k minus 7, but number of blanks also I need, so I can just calculate that, like number of even blanks and odd blanks. So here I have one odd blank and one even blank, right? So that is, I can just calculate that. So I have odd sum and even sum initially 0, and yeah, I have, like I iterate over the string I equal to 0 to s dot size, and odd remaining and even remaining. Like odd remaining is the number of blanks at odd position which are not filled yet, and even remaining is number of blanks at even position not filled yet, right? And then I can just iterate that my current, like my s of I, like at my ith bit, at my ith digit, which digit do I have? Like if I am at here, so I'll start with 2160, then 2161 dash dash, then 2162 dash dash, and so on, right? So I'll iterate over that. I equal to 0, I is less than s dot size I plus plus, right? And then okay, sorry, this is iterating over the string, and this for int cur equal to 0, cur less than s of I minus 0, cur plus plus. So like I am iterating from this 0 to the current digit minus 1, right? And then I will iterate over k also. So I'm iterating over k, like for int target sum equals to max of odd sum comma even sum, target sum is 72, target sum plus plus. So like what I am doing is I am looping over k, that was what is this k, and I will start with whatever I have initially. Like let's say if I am doing for 2162 dash dash, so I already have 2 plus 6 that is 8, and 1 plus 2, which is 3. So I already have 2 at 8 at odd position and 3 at even position. So like I want x5 plus 8 to be equal to k, and I want x6 plus 3 to be equal to k. So so k has to be at least 8, right? So I'll start k from max of odd sum or even sum, and k less than equal to 72, k plus plus, right? And ans plus equals to dp of odd remaining comma target sum minus odd sum into dp of even remaining comma target sum minus even sum. Okay, and then I update the odd sum, like when I go from 2161 to 2162, so this digit is increased, right? So I update the sum, like if this is odd digit, then I update the odd sum, and if this is even digit, then I update the even sum, right? So this is how it works. And finally, actually this number is left, like the r is left. Like let's say when I have 1122 as a number, or 1112, or okay, let's say 1122. So first I check for 0 dash dash dash, then I check for 10 dash dash, then I check for 11 0 dash, then 111 dash, then 11 2 0, then I check for 1121, but it ends here. Like I never check for 1122, right? So like if 1122 is also valid, that is if the current odd sum and even sum are equal, then I also have to count that. So ans plus plus, like this for loop does not count for this 1122, it stops at 1121, right? So I will increment the answer if the odd sum is equal to even sum, and I return the answer. Okay, so this was the code for this, and like it might be that you didn't understand some of it, so I recommend you to read the code by yourself, because this code is pretty well written. Like these variable names are pretty good, so I think you will be able to understand if you just apply your brain. Okay, and if you still don't get it, then you can either comment on this YouTube video, or you can DM me on Code Forces. Okay, like if you DM me on CF, I'll definitely reply. Like I might not be able to reply on the comments if I don't have enough time, but I'll reply on Code Forces definitely. So if you have a doubt, then you can DM me there. Okay, so that's it for today's video, and thanks for watching. I hope you guys understood the PCD, and see you guys later. Bye bye.